PhD student, and I'm in a proficiency phase. I'm studying about virtual spaces and its ontological status of virtual spaces, agencies in it, and something, etc., etc. And thank you for this opportunity because I'm very curious about game spaces. Thank you.
Oh, it's great. Thanks a lot. We need to like go one by one. Like let's have some pace at the beginning.
Hello, Mohammed. Can you hear me?
Yeah.
I'm just saying hi. I'm Michael. I'm a part of the Digital Futures team, so I'll just be in the background. The one thing I meant to say, I realized you've already started recording. Correct? I got the message on so because I think there's no real need to live stream necessarily if we can just record locally and then upload later, if that's fine for you.
Yeah, great. I already started.
Yeah, exactly, because the live stream is prone to a lot more glitches and stuff, so why don't we just do it locally, because we don't have much of a live audience right now anyway, I think. And I think maybe we don't get too hung up on that. But I'll just be in the background. I'm doing a couple other things and taking some screenshots here and there. I hope you all have a great workshop. I'm super excited for the topic, and yeah, I'm here. If you need anything, just drop me a message.
Great.
Awesome. Okay.
So maybe I will go over the list, okay? Because I know that once you start to do like this kind of online workshops, the audience is a bit shy. So maybe Asma, would you like to introduce yourself?
Can you hear me?
Yes.
Yeah, I'm Asma Ibrahim from Egypt. I'm 23 years old, from Faculty of Fine Arts Architecture Department. And recently I have been really interested in augmented reality, and I'm willing to learn more about it. So thank you for this opportunity of this workshop. Yeah.
Great. Really nice to hear that. Heba, maybe? Okay. Maybe Dawood?
Just give me 1 minute.
Okay.
I will introduce myself.
Okay. So maybe Taj, because you are already in the same room with me.
I don't know if.
Sorry.
Yeah. So. Okay. Yeah. So I'm Tej. I work. I'm actually studying along with Mohammed in Technical University, Ostwestfalen, and I'm in my second semester of my master's. And yeah, I'm really interested in this kind of stuff in software and coding. Yeah, let's see how it goes. Okay.
Okay, great. Kishan?
Yeah, so can I go?
Yeah, sure.
Okay, so first of all, hello everyone. I am Daud Asim Pracha from Pakistan. I am currently in my final year of architecture, bachelor's in architecture here in UET Lahore. For past like 1 year, now we have a change in curriculum. We do a lot of research in fourth year and make it like a thesis year. We call it a mini thesis year. We do two different projects, and I am doing for like past 1 year I am doing some work on gamification, uh, and but we are using Unreal Engine and seeing how we can incorporate everything that come with it. So I'm really excited about it for this workshop, and that's it from my side. Thank you.
Super nice to hear that. Thanks a lot.
Okay.
Kishan, maybe?
Hi, myself Kishan Prajapati. Can I audible?
I can hear you. Yes.
Hello. Yeah. Hello, my name is Kishan Prajapati. Recently, I am pursuing Master Science in Building Technology from Pratt University in USA. Uh, uh, my thesis topic is about the human comfort and neuroscience and embodied architecture. Inside, I am designing the alternative of brick modular block. Uh, Modular aggregation is one of my research part. I hope this workshop is helped me to learn a lot. Thank you so much for workshop.
Well, I hope so too. I hope it's gonna be helpful for you. Okay. Sana?
Hi everyone, I'm Sena. I'm a new grad architect and a master student in game technologies. I live in Turkey and I'm excited for this workshop.
Thanks a lot. Shiva?
Hi everyone, I'm Shiva. I'm from Iran. I graduated from master's degree in architectural technology with a focus on digital technology recently. And I worked on designing co-working spaces based on user experience through digital method, which I used virtual reality for my tests, actually virtual reality tools. So with my sister, we have a very small studio, as Enough Studio, you may know, because I joined this workshop with this name. Enough is the abbreviation of Innovative Architecture Flow. We both enjoy in very innovative methods in architecture and using new technologies, immersive technologies. And we try to be present in such workshops to know how other architects using technology in their works. So I'm happy to be here. I know that this workshop will be very exciting.
Yeah, thanks a lot. Yagmor?
Hello, can you hear me?
Yes.
I'm Yağmur Esendir. I'm living in Turkey. I'm studying architecture in Yıldız Technical University right now, and I'm interested in game design, and that's why I'm here right now.
Yeah, happy to hear that. Okay. So I think we have a quite a diverse group and super nice interests. And like as I'm always saying when I start to give a class, it's not me doing the show, it's all of us collaborating to have something at the end. So we should at some point form some groups, maybe today, like by the end of the day. We should start to collaborate together to have 1 or 2 prototypes at the end. I was planning to have 5 actually if we had the full 30 participants, but I would assume that we continue like for like how it is right now. But let's see how this will evolve. Okay, I have a small theoretical start, let's say, just to know what are we gonna talk about and how is it. And then I'm gonna give you an introduction about WASP and using grasshoppers for like this kind of like a statistical aggregation and so on. So we will talk quite deeply about aggregation today. I believe, like in my opinion, that in order to create like some kind of gamification approach to an architectural software, you need to actually understand not only game rules, but also the architectural rules of your building, the shape grammars. And in order to deconstruct this, I think the best way is to get into Grasshopper and try to deconstruct this into smaller components. That's why I believe it's quite important to go into WASP today. WASP can also be a very good testing tool for us to develop somehow an overview of what we can, like what kind of shapes actually we can get from this modular system that we would design. Yes. So I'm gonna share my screen. You need to confirm with me that you can actually see it.
We can
Good.
see the presentation. Yes.
Okay, great. So just a quick introduction. This project, building game, I have been developing for 1.5 years. I started this in one of my master's modules. And I wanted to create a Lego-like, somehow 3D Tetris system for building complex structures. That was the aim at the beginning. And for that, I researched a lot, multiple aggregation methods, cellular automata, also wave function collapse, and so on. And the aim at the end of those kind of voxelization systems is basically to have a very straightforward hierarchical approach to build complex structures. The photo you can see right now is like one of the outputs that we got from the algorithm that we have developed at this time. And the shift, the project talk at the end is how can we actually go into like the end of the loop, and instead of designing an algorithm and then the algorithm is going to build some kind of structures, how can we actually use gamification and augmented reality to build the structures ourselves? And for this, the workshop is going to focus on 4 main topics in the 3 days. The voxel logic system, what is the voxel logic, what is voxels, and some kind of like examples, how can you build a voxel logic system or an algorithm. And then we will talk more about gamification. We will check some examples like Sims, Minecraft. Minecraft is one of actually, I think it's the most famous example of a voxel logic system that is very well gamified. How many of you actually played Minecraft? That's not
I almost played like every day. So,
every day. Okay, good.
Yeah.
Also, Sana. Okay. Also, please correct me if I'm pronouncing the names wrong. Just please say, Mohammed, that's not how it is. Please focus. Yeah. So I think Minecraft is a very, very good example. I got a lot of inspiration from playing Minecraft to develop the project. And then we will dive deeper into the Meta XR SDKs, how to basically use it in order to create a augmented reality or virtual reality application. We will check the new API they released. How can you use the building blocks, which is the easiest way right now to build an application on Unity. And at the end, we will do some C# scripting and try to develop our own Unity AR application. I will help for sure, all of you, especially in the coding part. Maybe just to know how many of you knows C#, like just a basic understanding of C#. Okay, so, okay, Sana, okay, great. Taj, you also know some C#, right? Yeah, okay. So while we are forming groups, it would be nice if we can also split our C# experts. Yes, great. And also just another question. Do you also have some experience with Grasshopper? You can just raise your hand. Yeah, Shiva. Great. Okay. So this will be our last topic. The AR development on Unity. And right now we can maybe just have a quick understanding of voxelization. Basically, voxelization is gonna be somehow a way to take a complex object a mesh or this famous Stanford bunny, and then turn it into cubes or deconstruct it into cubes in order to build it in the easiest way possible. So if we can't basically sculpt this and we want to deconstruct this or communicate it to non-experts to build the same bunny, we have to get somehow a hierarchical method, a way that has been created, I don't know, 7,000 years ago. Because I'm Egyptian, of course, I will mention this reference, which is the pyramids, right? You can also think about the pyramids as a voxelization approach of building this pyramid. And this, I would say, the most intuitive way of building, or the most intuitive way of understanding a geometry. And that's why we need voxelization, basically. Voxel structures is super powerful because whatever can fit inside a cube can be used actually to create your structure. So the algorithm is the same. It's the same way that you are going to build it, but you can basically fit anything inside, which is the same thing like you can see in the video. And you can also see this here in the Habitat 67 project or the Nagarin Tower. It's also like it's the same method. It's a voxel and an aggregation, hierarchical aggregation way of building it, and then you have a fabulous structure. And in order to have to create the structure in a way that fits your architectural understanding, then you need to set up some rules and shape grammars. That's it, basically. You don't need anything else. That's the whole setup. And if you also think about it from a gamified approach, you can think still about the Lego, right? Lego is the childhood of many of us, right? That's how people start to understand geometry. Or at least that was my childhood. I don't know about you. Maybe you can share some experiences. But I got my first understanding about geometry from playing Lego. And if you think about it, Lego is also a voxel logic. You have a cube, and this cube has this kind of connection that can fit in a hierarchical way, top to bottom. That's how you can stack it. So then we have the cube, and we have the rule, top to bottom, and we have this kind of shape grammars that you need to fit it in 90 degrees, and that's it. That's the whole setup to define a Lego geometry at the end, or a Lego aggregation at the end. Why am I giving all this theoretical approach or like introduction? Because we will try to code this today on Grasshopper from scratch. We will start to build all those references today. We will start to understand how all those references actually works in terms of shape grammar and voxelization and aggregation. Is it well understood? Give me a thumbs up if it is. Okay. Do you have any questions regarding this? What I just explained. Okay. So I will stop sharing right now, and I will basically share a link with you of like the Rhino file that we are gonna use today. So you can follow up with me. You can find it in the chat. Or like, wait. To everyone. So you will find the Google Drive link in the chat. It's a Rhino 7 file. Did everyone actually did the setup that I have mentioned in the email, installing WASP, having Rhino 7 installed. Are we on the same page? Yeah. Okay. I see only one. Two. Three. Great. Okay. So I also prepared the Grasshopper file, but it would be like the best case scenario is actually you doing the code with me. So try to follow up with me and also ask me questions if you have any. I will share my screen again. So if you open the Rhino file, you will basically find 4 geometries here. It's 4 voxels. And we will start with this one. We will start by, so if you are completely new to Grasshopper and you want to basically get a component, what you can do is to double click on the canvas and then write the component you need. We'll just write geometry. Here it is. Okay. One other way of doing it is to go over all those tabs. I have too many because I'm using Grasshopper for a very long time, but you shouldn't have all those tabs. So you go over the tabs and then see what you need. We need geometry, right? We'll just pick it and then put it again in the canvas. If you right click on geometry, you can basically pick sit one geometry, which is gonna be the extrusion. And then we will try to deconstruct this extrusion. So deconstruct BREP in order to get its faces. We need all the faces to basically have all the so okay. Sorry, I need to explain this better. So the shape logic or the shape rules is gonna be created from the geometry itself. And in order to create this from the geometry itself, we have to go over all its faces to set up some planes. The logic actually works this way. We will consider this as a voxel. You can see me on the camera, right? Yeah?
Yes, we can.
Okay, great. So this is a voxel and this is another voxel. If I want to basically, or maybe no, I'll use the cup. If we want to connect this face to that face, we have to get a plane on this face and another plane on that, so they can basically connect. And we connect from the center point of this one and the center point of the other one. So center point to center point, plane to plane, and then it's gonna connect. That's how it works. Just to connect two basic geometries. So what I need right now is to get a center point and a plane. In order to get the center point, I will evaluate the surface and then reparameterize it. And then say, I want basically the point exactly in the middle. You see now what happened, right? I have the center point of each face and I have a plane as well already connected to it. But let's say I want a better setup for this plane. I want to define exactly the direction of the plane. Therefore, I need to use one of those two directions, the U direction or the V. And it just resembles the local coordinates of this face, basically. So what I need is to create a line. And this line is going to start from the center point and get the direction of the V. You see now what happened, right? Great. And then all what I need to do is to go into WASP. I have so many tabs, as you can see. But WASP has this set of components that you can use to create all kind of aggregations, like most of the things you need. And as I said, if we want to have like a connection between those two elements, we have to basically define the connection, and then we have to define the part is going to be connected, the voxel part itself. So we will define the connection first, and therefore we need this component, connection from direction, because we already have a direction and we have a center point, right? So our geometry is going to be this. Center point is to center point, and direction to the line. And now we have a WASP connection for each face. And this means that every single face on this voxel can connect to every single face on another voxel. You can change this as you want. It's not mandatory, basically. You can go to those faces and basically change its order, do whatever you want. That's up to you. But we will try to do the basic example right now. And then we need to define the voxel part. Therefore, we need to use this component, WASP basic part. We have to give it a name because WASP is very sensitive to names and how can I say it? Like if you have a voxel logic, you have to be very, very cautious about naming, because naming always helps to deconstruct the shapes at the end and do like have more control over the whole algorithm. And I will call it voxel. Interesting. Okay. Voxel. Great. Then again, geometry to geometry, connection to connection, and that's it. Now we have a WASP part. And all what we need to do basically right now is to do the aggregation. That's it. We will use this component, stochastic aggregation, part to part. The number, let's say that we can start with 60 voxels. And we have to define rules for for this aggregation. And the rules are basically gonna be generated from the connections, right? We have already defined the connections. We defined the direction that we need, and then we can just type rules and pick WASP rules generation, because it's just gonna generate the rules from the connection. Part to part, as always, and then rules to rules. Great. All what we need to do is to have this button to basically reset the aggregation every time we need to do that. Okay, if I try to preview this nothing happens for sure, because right now the only thing we have is the WASP parts. And we basically need to just visualize it. So we need to change the type from WASP part to a geometry. And now this is basically our aggregation. We can reduce the numbers. We can go higher. And you can see actually that every time I change that, basically the order changes, because it's continuously, it's basically continuously computing the possibilities. I'm just gonna start from 2. So what happened is basically this phase to that phase, and then it goes more like over and over again. It goes over all the shapes, picks a random one, takes one of its one of its faces and connect it to one of the faces of the next part. Because right now we don't have custom rules. We have this kind of not random rule, it's random rules, but yeah, it's not really customized so far. So we have this beautiful aggregation at the end. If you are new to Grasshopper, you can basically type custom preview, and then you will have a material for your shapes. If you want to change the color, then type swatch. We can pick this beautiful pinky color. And you can basically change the opacity, change the intensity of the color, do whatever you want. So that's the basic example of a WASP aggregation algorithm. Is this clear? Give me thumbs up if it is. If it's not, please also ask your questions.
Please, can you use bifocals component?
Yeah, sure. Okay.
No, thank you.
Better?
Yes, thanks.
Okay. Yeah, thanks for reminding me. Actually, I also wanted to do that, but I forgot. Okay. So I hope this is clear. One thing that we can add to this definition is to have some attributes to we can just use this component WASP attribute. And the attributes is basically giving us the opportunity to put something predefined into this voxel. So from center to center. And I don't want anything fancy right now. I just want to change those meshes because I don't want to see those mesh edges, let's say. I want to replace the mesh with a VREF. So all what I need to do, put whatever I want to put inside in the value, give it an ID, because we said it's very sensitive to names. I will call it VREF. And then put a toggle basically to turn it on and off. I want to turn it on. And then we attach this to the attributes. And that's the first thing to learn actually about how WASP is very sensitive to names, or aggregations are very sensitive to naming in general. If we go to get attribute by name, and then part to part, take this ID here. Yeah, I need to refresh. Yeah, sure. Okay, great. Then we will only get the VREF. If I change this, now we can only see the VREFs. This actually works for almost everything that can fit inside this box. And I have already prepared some geometries. As you see, this amazing octahedron, we can already use it as an attribute. So I will define it the same as a geometry, set one geometry, put the geometry inside the value, and then yeah, because it's okay. That's actually quite interesting to happen. Okay. No, I know why. Okay, sorry for that. It has to be actually in the same center point. So yes, now it is. So as you see, this is basically our initial voxels, and those are the aggregations that it's gonna fit inside. It works the same way, exactly the same way. And I believe this is actually the beauty of voxelization, that whatever you want to voxelize, whatever you want to aggregate, just fit it inside a voxel and aggregate this voxel, and then you are basically done. If you just need to get a hierarchical aggregation of any shape, fit it inside a box, do the hierarchical aggregation for this box, and then you are good. So, is it clear? Do you have any questions? Okay. In the file you have, I already prepared multiple shapes to basically also fit it inside. So you can play around, you can use the octahedron, you can use the those kind of cross structures. Just try to play around and understand how it works. And I mean, as I told you in the beginning, we will try to basically deconstruct every example that I have showed. And therefore, now we understood how voxelization can work using WASP. Let's actually try to set this up for the Nagakin tower and check how it works. How can we actually create the same shape in the same order and have an infinite aggregations out of this? I will do almost the same setup. Nothing is gonna change. Only few stuff that's gonna change. If you want to follow up with me, basically use this voxel here. In this voxel, I have two things, basically. I have the extrusion and I have the poly surface. I just need to look over the chat. Okay, I'm really sorry, but maybe I can go also slower. I will do my best. But at the end, you can also find a Grasshopper file in the shared folder. Like use the same shared folder. I will use the same shared folder for sharing all the workshop material. So you can also follow up on your pace later. Okay, now it's time to create the tower, right? And to create the tower, I will basically use the same setup. Nothing not a lot of things will change. I will use a geometry. In the geometry is gonna be the extrusion, the voxel itself, set one geometry. And then I will start to create the connections. So I will deconstruct the BRAB. It's really interesting. Yes. And since for this example, we actually don't need to have connections on the sides, then we need to basically have a top and bottom connection. This is our first introduction to custom rules, basically. So for that, we need to basically have a connection for the top and a connection to the bottom. You can use the list item component. 6, right? So 0, 1, 2, 3, 4. 4 is the bottom face. So this is the one we are going to start with right now in order to get the connection. And then we will evaluate the surface, try to reparameterize it so we have an accurate estimation of the points. This then should be the center point. Yes, great. And then we need to create a direction, basically. So a line. And then we set up the directions, right? And then we need to set up the connection. So was connection from direction. Again, geometry to geometry. Center point or like points should be basically the points of those lines, because now I have two. So I'm gonna use endpoints to get it. And this is basically the direction. And now we are good. One thing that we can actually do here is to give it a name, every connection, because we have multiple ones. So we will call this bottom. That's the first connection. Just all what we need to do, we need to just copy paste it to create the other connection. We will go here and see which one is the face above. So it is basically number 5. And then we have already the lines, we have the directions, we have everything. It's like as I said, it's parametrical approach. So it shouldn't be a big problem if we just copy paste stuff, change one thing, and everything is gonna work the same. Great. Now we have connections, but for this one, we need to change the name to top. Great. And I think now we are good. We need to create the part. For this one, we will use the advanced part. Like personally, I just want to introduce you to it, but you can also use the basic part. It doesn't matter. We will give it a name, and we can call it capsule, because they call the parts in the tower capsules, right? So geometry to geometry, connection to connection. And we need to basically set up attributes. Why do it, like, as I told you, we use the attributes to basically fit anything we want inside the voxel. And this can work for multiple objects. So if you want to put this cup basically inside the voxel, you can, no problems. But you can also add more details to your voxel. So if you have windows, if you want to create somehow like some kind of, I don't know, slabs, columns, I mean, whatever details you want to add to this voxel and you want to put it inside, you can use the attributes for this, okay? So we are going to have an attribute for sorry, today we are doing the workshop in the university, in the office. So yeah, we had a visit. Yeah, so let's get back. We need to basically create like this attributes for a detailed version of this capsule to basically fit the same shape that we had. If we look here, we have a window and we have the groove of the window itself inside. Please also note that we have double the size of the voxel. Right now we have only 1 cube, but we need to double it. So those are the 3 steps we need to do. We need to have details for the detail for a window, detail for the groove, and we need to have double the size of the voxel. Why I didn't do this at the beginning, like why I didn't do this kind of double size at the beginning, because in my opinion, it's always nice if you keep the hierarchical approach to a voxel kind of shape. If you have like if you double size it or like if you scale it in one direction, then you are somehow losing the control over it. Because as I said, the connection is going to be from the center point to the center point. And if we double the size, it's going to basically connect on places that we don't want to. We want to exactly have the same hierarchical aggregation, right? So we go back to Rhino. And we will do the first thing first to have a groove detail. I will call it detail. And just to get it, I will do a new geometry, set one geometry, and then I will pick the poly surface. Okay. And just a toggle to enable it and disable it. That's basically number one. Number two, we need to have window, right? And for that, we need to set up the geometry that is somewhere here. Yes, yes. So this is gonna be our geometry basically for the window. And as we did, attribute to attribute, and then shift, drag to attribute again, and then our part is basically ready. What do we need to do today? We need to have double the size of this voxel. And in order to do this, we have a component for transformation of the WASP part. So WASP transform part. And it's just a replacement for a move, but in the understanding or in the logic of WASP. What do we need to do? We need to do part to part and then mirror this object, right? So mirror. We don't need basically to do like we don't need to attach the geometry because it's going to be the part. We just need the transformation. And we need to set up a plane basically for the mirroring. And I think the only possible or reasonable plane is going to be this one. You have two options to do this. The first one is just to create a surface like this, right? And then this is going to be our plane. Set one surface, and then plane, and then transform. And then our part should be ready. If we try to visualize it, we can see it already here, right? Fine. I hope it's understandable. Great. I think what we need to do now is to create the aggregation, right? So we will start with aggregate. I don't know, the WASP has a very interesting way of not showing up, but that's fine. Sorry. So part to part, we will set a number of 30, let's say. And then we are going to generate some rules. But I think first, what I forgot to do is to basically create another part after the transformation. And in order to do this, it's also the same. I will call it full capsule. And then the geometry should be the deconstruction of this one. So it's gonna be those meshes, basically. And then we have one mesh at the end. This is gonna be the geometry, and then connection to connection. And what we need to do now is to basically connect, is to also connect the attributes, right? Please let me know if you have questions or if you don't understand why are we doing this right now. So we need to basically have a transformation of those attributes. So we will deconstruct it. And then, and as you see here, that's actually the full capsule that we need. And it works fine. I will just try to match the text. So text to text. Need to just copy paste it. Yes. In the text, I would just try to match detail. So we check for every object that has the name detail, basically. And then give it the name again here. Then we have the attribute again for the new shape. And then we do the same. Check for every object that has the name window. And then give it the name window again for the new double-sized capsule. And then attach it to the attributes here. I think first I need to fill out in this. Yes. Great. So part to part, number to number, and then we have to create the rules again. That's my favorite part. We don't have to think about anything anymore. And then we just add the rules. And then just in order to like show everything, we will need to, no, not toggle, we need the button to reset the aggregation. We will have to do the same thing that we did in the first time to basically sort by name. So part to part, and then I will add the name detail to see a detailed version, and that's it actually. So now you can see it. If we want to do the same and get the window, then I just need to connect window to ID, and now the window is also visible. Good. As I told you, we need to do a custom preview component to give some colors. Say, let's try to give it like some kind of concrete color. Or do you want something else? If you want another color, you can also tell me. Good. Like to have it like faded a bit, and then also give a color to the window. Maybe, you know, something in this direction. Something like that. Yeah, and we can have more of those. We can have less for sure. We can reset to create new variations. And as I said, once you start to understand the logic of aggregation, it's actually easier to do this in Unity. We can't jump into the Unity part like completely without understanding the custom logic of aggregation. Now we have a good setup, right? Now we know how to create like shapes like the tower. Do you have questions? Is it clear? How many of you actually can follow? Okay, can you maybe just tell me a feeling? It's actually quite hard to be the only one talking. I need some interaction. So can you just
Sorry,
your feeling?
could you please share this algorithm with us? Actually, my screen is really just, I have my laptop and it's very difficult to follow the video and also try to work on Grasshopper. So I miss some components, and because of this, it's a little bit hard.
Okay, I can just upload it right now. I will stop sharing.
Thank you so much.
Yeah, now it should be in the same folder. Okay. Last but not least, and I would say it's my absolute favorite actually, is how to create an algorithm to build Lego objects. I have already like a setup that I have developed before. Can you see it now? Yeah. So this setup is basically giving me the opportunity to create multiple Lego aggregations. And I can have more of them. I can have less. I can change the order of them. And I will just also explain it to you now, because it's, I think, one of the most important things that we are going to check in this workshop. At the end, it would be super nice if we can develop an application that is simulating some Lego logic, but in scale of buildings. The good thing about augmented reality that you can build in real scale, right? So you can use the lenses, you can use the controllers to do basically exact same thing, but in real scale and in real environment. One of the tests that I did before is a Minecraft game that I have designed in a real scale of block 1 meter by 1 meter. And we used it here in the university to basically rebuild the campus again in augmented reality. And I think one good example of this is also to build, and what I want to collaborate and like check with you is how can we also try to do this for some custom Lego objects. You will find this example in the Grasshopper file I have shared already. You will find also the voxel, should be this one. You can experiment with this, but just try to follow up with me how to build it yourself. So the setup is, as I said, exactly the same. We really don't need to do anything more. We can just copy paste the part that we have done here. Just copy, paste it. I will need just to change its name to Lego. And set the geometry, which should be I think it shouldn't be this one actually. Yeah. Okay, maybe, yeah, it should be the extrusion. This should be the first object. And it's exactly going to be the same. Like if you look here, we have the top connection there. We have the bottom one. Yeah. So we have our connections already from last time. And we just need to set up a new attribute to have this custom shape of the Lego. So geometry, set one geometry, should be this one. Great. And then we will have a name for this. I will call it Lego brick. And then we need to toggle it. And just need to connect this to attributes. So basically that's it. And then basically like last time, if we want to have like double the size, triple the size, I don't know, 5x even the size of this voxel, we need to do the transform. So transform wasp part to part, and then we need to do the transformation, which should be a move. And this move, we need it to be in the direction of, so if you look here, this is X, Y, and Z. I would go for the direction of X. So this is the direction of X. Put it in motion. And then we need to create multiple moves, actually, which we need to use a series for it. So this is the size of the voxel itself. It's 13 centimeters, and I need 5 of it. Great. And then we need to attach this transform. And if we try to visualize this, here it is. Those are the 5 blocks in one. If you see, we can have, I don't know, however you want. We can stick to 4 right now. And then we need to deconstruct this part. Again, I'm doing the same mistake of checking for the parts. Great. If we deconstruct it, we need to have all the shapes at once. So we need to union the shapes. That's it. Great. And create an advanced part again. So geometry to geometry. The name now should be Lego 4X, let's say. That's the name. And we are going to also deconstruct the attributes again. Connect. I mean, you can see already here, right? But it's started to be the Lego brick that we want. And then we will basically take the value of it. Try to union also the B-reps. Now we have one B-rep. Good. And we will create a new attribute of the unified geometry right now. We will use the same ID, which is a Lego brick. And we will set a toggle to activate it and deactivate it. Great. Sorry. Yes. Now the best part is to do the aggregation, nothing else. So part to part, Maybe we will start with 20. And we will generate some custom rules this time. So we are not gonna only use the normal ones. We will also create a custom rules. And in order to create a custom rule, we need to type it basically. So we need to do it like top to bottom, bottom to top, right? Because it has to be stacked in a way. So this is how the Lego bricks are being stacked actually. A brick, and then another layer, another layer, and another layer. So for the first layer, we need to connect top to bottom of the next one. And for the next one, we need bottom to top. So I will write this. I mean, you just do this and then type it top to bottom. And then the next thing should be bottom to top. We will multi-line the data, so it's a list. Put it here. Now we should actually have the rules, hopefully. I think I messed up something. I messed up the connection. Yes. So now we should have some rules. Great. And we would just add it here. And then we have a toggle to, not toggle, sorry, button to reset everything. And in order to visualize the part, as we did multiple times right now, is to get attribute by name. So part to part, and then connect it to the name, which is a Lego brick, right? The detailed version of it. And now we can see it. Now that's an aggregation of Lego bricks. And you can see that it's perfectly aligned, right? So we can have more. And we can also change the order of it. And one thing that I actually love, and I used it a lot to create some games, and maybe this is the first game that we will do today, is to check for those objects, let's say. So I will flatten it. Yes. And now we have exactly 48 objects. I will get the center point of those objects. And every center point actually of those has XYZ, right? So we will deconstruct those points to get the Z value. And Grasshopper has something amazing called sort list, which will basically sort all those Lego bricks in some way that we will define it. The way I want to define it is to get it in a hierarchical in a hierarchical order. So I want the first one that is like in the base. So I want the base first, layer number 1, and then layer number 2, and layer number 3. So this is gonna be our keys, right? And then those are going to be the things that we want to order. List item. So we have the first one, right? Right. And if we basically try to create a series, and the count can be, I don't know, 12. Sorry. Yes. Then we will basically select those objects based on their hierarchical method. You know what I mean, right? So we will take, so this is basically the first one, right? And then the second one, the third one, and we can use this as an assembly guide actually, right? If we hide everything, so we only see our game, we can already see that This is the number 1. Number 2 will be next to it. Number 3 will be on top. Number 4, 5, 6, and so on. And this will be a really, really nice way of actually assembling our structure that we have created from the algorithm, right? So we created an algorithm for the aggregation, and then the game is to basically sort it and get an assembly instructions to how to build it. And now we have our complete set of Lego. If you want to change the initial setup, if you want to have different objects, if you want to have different colors, all of this can be implemented, but it's exactly the same method, but you will just need to add more details to your attributes. Okay, it's almost 1.5 hours now. So time for questions. Now I finished my first part of explaining aggregations. I don't know, if you think about it in a way, if you have some experience with Hologram, you can basically connect your phone to Grasshopper right now, and only visualize this component in Hologram. And once you do this, basically you can have like those, like exactly same, like if you have the same set of Lego, let's say, you can basically do an AR assembly game right now of Lego objects. If you have any Legos at home today, just check it, like see the dimensions of this. Try to change the dimensions. I showed you already like how I did it. So just try to do it the same way. And I can show you like how we can also connect this to Hologram. And then you have your first AR voxel logic game. Yeah, and as I told you, just this slider, like if you control this slider on your phone using Hologram, you can see what's the next part. And one thing maybe would be interesting for you if you want to research this, it's super, super nice. You can use also WASP to populate geometry. So the same, I can just show it to you again. So if you have a geometry of this Stanford bunny, if you have a geometry of, like here, as you can see here, of a chair, if you have, it's, I guess in my, yes, it's in this slide. If you have this kind of pavilion, any kind of surface or a B-rep or anything, you can also use WASP to populate it with your shape, with your voxels. And then you can have this kind of shape generation algorithm that is turning in augmented reality into an assembly game. And now we have Lego at home. That's that was the aim of the first session, or like the introduction that we had today in the morning. So now it's your time to give me some feedback.
Hi. If we want to create a boundary surface of this, like I have one form, like a sphere, and I want to aggregate in sphere, then what kind of command we can use and we can aggregate in this shape?
So you want to aggregate the sphere inside a voxel?
I want to generate one boundary for, like now it's aggregating on one algorithm, but we make one boundary of this algorithm. It's not go outside of this boundary.
Yes.
Okay. So how can it's possible? Like,
I mean, so you want to basically aggregate a sphere, and this sphere doesn't have to fit the boundary of the voxel, right?
no. Like our last exercise is like a Lego. Lego is orient in tree kind of geometry, but we restrict one sphere. It's like a grow in spheres, like a tree kind of, but if we make it one boundary, that shape are not grow outside of this sphere.
So the sphere is gonna be the
Like
boundary
a
that we should
boundary
fit.
surface kind of thing.
Yeah. So the sphere should be the boundary, and we should fit the Lego inside. That's what you want to say.
Yeah.
Yeah. So what I said basically is, yes, this is possible, and it's almost the same setup as well, but we just need to change like a part at the beginning, and that was basically my task to you right now, is to check the possibility of doing this and try to do this like on your own. Basically, that was my thing, like the thing I said right now, that it would be nice, like if you are interested in this direction, then this is the part that you can add right now.
Yeah.
But we will do it together. Like it's just like I just would love to give you this part to think about it, and then we will do it anyways.
Sure. Thank you.
Okay. Any more questions or suggestions? Don't be shy, please. Okay. But you can also give me like your opinion. Do you think what we are doing so far is interesting? Do you think it's interesting, but yeah, I need to check it more, I need to understand it more, or we have to maybe rethink the direction? I just think that it's the best way to explain this way of thinking, let's say. It's not that easy, unfortunately. And right now we are using WASP, but when we start to do this on Unity, we have to code something similar to WASP on like on Unity. I will help for sure with this part, but that's just like a way to understand it. So what we will do next is basically to populate a geometry, as Kishan already suggested. This would be interesting. But first thing first is for you to think about it right now, to think how can we actually do it. Try to think even theoretically how this should work. If we want to populate this sphere with Lego bricks, how this should work, how should we think about it? Try to do some research about how this can be done in WASP. I think this can be interesting. And since I don't believe that anybody can follow anymore after 1.5 hours, so I would say that we take a break, if that's fine for everyone. How do you feel? Yeah, good. Yeah, so maybe we take an hour of researching what I said, try to create like a small proposal, how this should be done. Try to even sketch it. If you have some Grasshopper skills, please open Grasshopper and try it on yourself. I'll try it yourself, sorry. And yeah. Sorry, I need to follow that chat. Yeah, sure. Please take your time to understand how it works. But one thing that I believe that's actually super, super important is to learn by doing. And if we got, which part is more complicated? That's, I don't know, that's a hard question. But I would say the Unity part is more fun than the Grasshopper part. Grasshopper is dry and it's more coding oriented. With Unity, we can have some fun actually. So in the break, like after the break, we will get the Unity introduction as well. How to set up the Unity SDKs, how to like start to do some basic examples and so on. But yeah, sometimes you need the dry introduction in order to like create something nice, right? Yeah, that's the amazing computational design. Sometimes it's too dry, and since we are designers and we are not really trained to like do those kind of complicated tasks, it gets super hard. But I believe that it's super important as well. We need to understand the theory. We need to understand the mathematical part of this. We need to understand the algorithmic part of this, so we can actually think beyond and we can change it. We can adjust it or customize it to what we want. So I would say that's our checklist right now. We had our WASP introduction. We created our first game. And what we need to do right now is to have a small change to this game, which is making it work the other way around. We have a shape, and we want to populate this shape hierarchically with the with the Lego bricks. Try to research this, try to think about it, try to even sketch it. Just think, just try to think, use what we were doing today in order to have a good proposal for this, okay? And at 1:30, we meet again. We do the example on Grasshopper, and then we open Unity and get our introduction to Unity today. By the end of the day, I would say that we should, like everyone individually, should actually start to work on a proposal of a game that is using the voxel logic, which we explained today. And while using the voxel logic, we will try to adjust it to the Quest, the controllers, the lens, using like the immersive environment around us. And once we have this, we can create some nice, we can shape some nice groups and start to do the game tomorrow. So tomorrow should be our Unity development day. And today was the introduction for everything. Good. Sounds fine. I need to see a lot of thumbs up to feel that we are on a good way. Nice, 3. Yeah, that's amazing. Great. So we meet again at 1:30. Please prepare your proposals. Just for this small problem that we were talking about the Lego game. Please think about it. Please don't be scared of this. Just do it. Just do it. Just do the thing. That's it. And then we will do it together and try to have some fun with Unity. Okay? Okay. Enjoy your lunch. Or I don't know about the time zones, but here it's lunchtime. Maybe you can also tell me if it's too different. 2 p.m. Okay. 2 p.m. can also be lunchtime, right?
Yeah, it's lunchtime here also. But I have a small question, not related to workshop, but what time do you have there actually? Because here I have 3:32, and you are saying let's meet up in like 1 o'clock.
So right now for me it's 12:37.
Okay, so it's almost like half an hour. Okay.
So what I say about time is Central European time.
Okay.
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 Okay. So let's say we have 40 minutes, right? We come back at 2. I would say 1:30. Is 1:30 fine for everyone? Fine? Okay. Okay, great. Then please try to think about it, eat something, relax, and start to be ready for the next part. Fine? Okay.